Hello and welcome to yet another lecture on basic electrical engineering. Myself, Prathita Roy, Assistant Professor of Dr. Sudhir Degree Engineering College, Electrical Engineering Department. So today I will discuss about the three-phase balance system and the delta and star connection, and along with the conversion of delta to star and star to delta connection. So in order to find the three-phase balance system, so we are dealing with the three-phase system. Three-phase balance system. So what does the term phase means? Phase means sets of windings. Phase means, first of all, we have to know the phase. Phase means sets of windings. Phase means the sets of windings. So three phase means three sets of windings. So three phase means it will be three sets of winding. So three sets of winding, they are separated in space. There are two type of phase displacement. One is called the spatial phase displacement, means they are separated in space by an angle called 90 degree. They are separated in space by an angle 120 degree apart from each other. They are separating in space, and they are in time, they are separated by an angle 120 degree. How? So this three phase is generally known as R phase, say the red, Y phase, the yellow, and the B, the black or blue. You can say anything. RYB phase. Okay. So they are in space. They are 120 degree apart from each other. So now in time, that is called a temporal phase displacement. So if I apply a voltage, that is VR, that will be, say, Vm, the maximum value of the sinusoidal voltage, sine omega t, means in time domain they are separated each other. Say Vb that I am applied will be the Vm sine omega t minus sine omega t plus 120 degrees. Say. So that is a phase displacement of 120 degree, and another is Vy, say Vm sine of omega t minus 120 degree. So now it is seen that they are in space they are 120 degree apart from each other, and in time domain they are 120 degree apart from each other. All the magnitude are same, that is called the Vm, and this is called a balanced three-phase supply. So in order to generate a magnetic field, we have to apply a balanced three-phase supply. Means the magnitude of the supplies, all the supplies in the three phases are same, must be same, and and they are in space they are 120 degree apart from each other, and in time domain they are 120 degree apart from each other. This is called a balanced three-phase supply. So what does the phase means? Phase means there is a three sets of windings that is connected, are known as windings, that is known as phase, three phase. So this type of connection, it is then known as Y connection because it seems like Y or the star connection. Y or star connection. So another connection is generally there is called the delta connection. So the delta connection is there. It is more like that. This is called a delta connection. So then two types of connections are there in case of the three-phase system. And this is called the neutral point. This point of the start connection that is called neutral point means this point is directly grounded. With the help of an wire, this program is directly grounded. This is three-phase four-wire system. Phase is three, but wire is one, two, three, four. So, and this is the three-phase three-wire system is another that is called the delta. One is called the delta connection, and another is called the star connection. So you will see the relationship between the delta and star connection, and what are the different relationship between the voltages and current in case of the delta and the star connection. So the star connection is generally given there. So this is the star connected supply, and along with the this is the star connected supply, and along with the load is connected in star. So it is seen that the voltage VR is fed to the R, voltage VY is fed to the Y phase, and voltage VB is fed to the B point. So VB means the voltage difference between this neutral and the B phase. So this is called the phase voltage. The VB is known as VBN or this VB or neutral. There is a voltage difference between the a phase and a neutral is line and a neutral is known as phase voltage. VB, VR and the Y. So VBN, VRN, and VYN. This is generally known as phase voltage, the voltage difference between a line and the neutral in case of the star connection. And also VR, VY, and that is a V. And what is the line voltage and phase voltage? First, we are uh, in the conception of the phase voltage. That is, the phase voltage is the voltage difference between a line and a neutral. That is VB, VY, VRN, VBN, or VYN, and the voltage difference between the two lines. The voltage difference between the line R and voltage difference between the line B. This is called VBR. This is called the line voltage. Same VRY, voltage difference between the R and the Y. And same in case of the VYB, voltage difference between the Y phase and the B phase. This is called the VYB. This is called the line voltages. The line to line voltages. Okay. So let us take that the summation of the current that is called the line current IR, IY, and the IN. The summations that is the current that is summing out from the voltage current flowing to the R is the IR, R wire, and the Y is the IY, and in case of the B it is the IB, and the total summation of the current is IN that is turning back to the neutral point. So IN equal to IR plus IY plus IB. So it is seen that all the currents that is IR and the IY and the IB means current in the phase and current in the uh, line both are same. That is current that is flowing through the line, that is current flowing through here, it will be connected to this and routed through that way. So means connect in the phase current and the line current are same in case of the star connection. So we can conclude that here for the star connection, the phase current IP will be same as the line current IL in case of the star connection. And now what is the delta connect? Now what is the voltage? Voltage profile is seen that we are, if I draw that voltage are VR, that we have seen that VB is 120 degree apart from each other. So what is VRY? So if I can able to draw the VRY, if I able to draw the VRY, so VRY means VR minus VY. So say this is R phase. It is very easy to draw. This is Y. So this is R phase, this is Y phase, and this is B phase. So this is R, this is R, this is Y, and this is B, and they are 120 degree apart from each other. 120, 120, 120. Okay. This is R, Y, and B. So VR minus VY. So minus vi will be like that, and the resultant will be like that. That is called the resultant, the minus y, and that is the resultant. We will find that v r y. Minus y means magnitude will remain same. The direction is changing. Same, and that is given here. It is the angle will be 60 degree. It is half. So the total VRY value will be VR square plus Vy square plus 2 Vy cos phi. That is VR means the V phase voltage. VR is always the V phase voltage. So it is given, calculating it will get the root 3 into VPH. V while V YV equal to same root 3 into VPH and VRV equal to root 3 into VPH. So it is found that the live voltage in case of the start connection, I concentrate the start connection, the line current will be same as the phase current, IL equal to IP. But whatever we have seen that the line voltages, that is VL, will be root 3 times of the VPH. Because it is, if it is connected to a voltage source, say this is connected to a voltage, three phase voltage source, RYB, and this is the neutral. This is RY and B phase. This is IR current, and this is IY current, say, and this is IB current. So it is seen that the three currents, the line current and the phase current, both are same, but the line voltage is root 3 times of the phase voltage, the magnitude of the line voltages. Now, in case of the delta connection, so delta connection, it is seen that all the line voltages from the connection, it is easily seen that the line voltages and the phase voltages are same. So if I draw the delta connection, we will see, if the three-phase power supply is given like that, R, Y, and the B, say the voltage, that is the, this is R, Y, and the V. So the this voltage, the V of RY, the line voltage will be same as the voltage. This is the R phase, this is the Y phase, and this is the B phase. So say if I consider this is VRY, it is same as the voltage of VR, or say VRN means the phase voltage, and also same in case of the Y and the B phase too. So for the delta connection, the phase voltage will be equal to the line voltage. But only there is a change in the current. The current that is coming out, say that is IR, IB, and IY in the three phases. And we have seen that the I1, that is IR minus IB, that is coming out, and I3 equal to IB minus IY, and I2 equal to IY minus IR. So IO2, this current, this will be the IY, and IR that is coming out from here, and this is the, what is the I1 value? This is the IR, and the IB is going from there, so it is IR minus IB. Now at that point, the IR, IY is coming here, and IR is going out, so it is I2 will be IY minus IR. So what is the, this value I3? I3 will be the coming in is the IB, and going out is the IY, so IB minus IY. So let us concentrate on the phasor diagram of the current in case of the delta connection. It will be same as like that we have done in case of the that's that we have done in star connection. It will be same. The phasor diagram will be same. That is the that we have done in case of the voltage. So it will be fine that it will be 2/3 into the phase current, that is the I1, because I1 is the generally it is IR minus IB. So this is IR and this is IB. So let us concentrate on only one part so we can understand all the parts. So what is I1? I1 means that is the IR that is coming here, and IB is going from there. So at that point, it is IR minus IB. So let us concentrate on that. Say this is the current that is coming here is the IR, and it is the current that is say IY is going here. So only concentrate on that particular point. So the current on the particular one that is current that's leaving called I1, that will be IR that is entering, and the leaving is IR minus IB. Okay, that is given here. So if I draw the phasor diagram, now it is seen that they are 120 degree apart from each other. Say I am concentrated on that is IR, that is IB, or say IY, and that is IB. Okay. So what is I1? I1 is minus IR minus IB. So this is the minus IB. So the angle is 60 degrees. So this is the resultant value of I1. The I1 will be IR minus IB. Minus IB means the direction is changed of the IB, but the magnitude will remain the same. And for that point, we'll same find for that point also and for that point also, and it will see that the phase current, it is given that after all the summing point for a part, if I do it, that is what is the value of the particular part, it will be seen that it will be IR square plus root over of IR square plus angle is 60 degree between them, all are 60 because that 120 degree total is the 120 degree apart. So it is found that will be I square, the calculations, plus IV square plus 2IR IB cos theta, it will be found that root over 3 into PH. So it is found that the line current will be root over 3, the line current is the root over 3 times of the phase current. The line current will be root over 3 times of the phase current in case of the delta connection. So that is easily known. So in case of the delta connection, the line current is 3 times of the phase current. So let us concentrate on the power calculation. So for the delta connection and the star connection, we are calculating the power, three-phase power. We are calculating the three-phase power calculation that we have done for the delta connection and the star connection. So for the delta connection, this phase voltage equal to, it is given that for a delta connection, that is the phase voltage and the line voltage are equal, and the phase current will be, it is given for the delta connection, the phase current will be this one, that's the 1 by 3 times of the line current, 1 by root over 3 times of the line current. Now in case of the star connection, the line phase current and the line current are equal, that we have proved, but the phase voltage will be 1 by root over 3 times of the line voltage. So let us power. Power means for a single phase, power is V into I into cos theta. Same here, for the power in the single phase will be V, three phase into the combination of star and delta connection. Cos. But a power in a three phase line, single phase line. So power in the three phase means you have to multiply it with the help of per phase will be in case of the three phase analysis, the analysis is done on the basis of per phase. Okay. So this is the power in the single phase. So power in the three phase, we have to multiply it with the help of three. Multiply this with the y of help of three. So now I am converting. So this is the VP. I am considering that is a per phase analysis. So this is the voltage. This is the power in the per phase. So now root over 3. So VP will be replaced by in the delta connection VL. So IP will be IL by root 3 into cos phi. So the total power became root 3 because it can be written as root 3 whole square VL IL cos phi in case of the delta connection. So now in case of the star connection, VP can be written as VL by root 3. So IP is IL cos phi. So the total power in the star connection is root 3 VL IL cos phi. So it is seen that irrespective of the star or delta connection, the total power in the both cases are same, that is VL IL cos phi. So all the mathematical problems are given on the those data that given on the mathematical problems are given on the line current and the line voltage. So we have to run to just multiply it with the root 3 VLIL cos phi is the power, phase power for both star and the delta connection. Now we will see the transformation from star to delta or delta to star. So how we can convert a circuit from star to delta or delta to star. Let us start from the delta to star network. Now, the conversion is from delta to star. So a delta connection is given like that. Say this is given as ABC. We have to convert it to an equivalent star. We have to convert it to a equivalent star connection. So this one, this one, this one, this one. This is the equivalent star connection of the delta, and name is given as P, Q, and the R. Name it given as P, Q, and the R. The point is 1. So what is the value of P? Converting delta to equivalent star connection. P will be, P is connected between the A and B point. So what is the value of P? P is connected between A and B points. So P can be write as A into B from delta to star. A summation of all the other resistance or all the other arms. A plus B plus C. Okay. So Q can be written as Q is connected between A and C. So it is AC, A into C divided by A plus B plus C. Where that the R is written as R is connected between C and B, so BC divided by A plus B plus C. This is the conversion from star to delta. Star to equivalent delta. Star 1 is converted to delta 1. PQ, PQ, and that is the R. This is the formula to convert a star 1 to a, this is the conception network that is used to convert a star 1, delta 1 to a star 1. Let us take an example. This is given 30, 20, and 80. So what is the value of Q? Q will be this one connected between A and C that I have done. Q is AC into A plus B plus C. So AC means 20 into 80 plus total summation is 130. So 12.31. So what is P that I have done? P is the AB by A plus B plus C. So 20 into 30 AB plus 130 is 4.61. So what is RBC that I have done? R equal to BC into A plus B plus C. So 30 into 80 by 130, that is 18.46 ohm. That is called the start to delta connection. So delta to star connection. Now we are connecting on the star to delta. If a star is given, now I can convert it to a delta. Now I am converting to the star to delta. A star is given like that. That is P, that is Q, that is R. I am converting into a delta 1. How I can convert the delta? Delta. This is called A that I have written. Let's see. This is P. So what is the value of A? A is connected between P and Q. So A can be written as PQ, connected between PQ, and left one is R. PQ by R plus the summation of 2, that is P plus Q. So what will be B? B is connected between P and R. So PR by the opposite side, that is Q, and summation of P plus R. So what is the value of C? C is connected between R and Q. So RQ by P summation then plus R plus Q. So that is the why we are finding the equivalent delta. That is A, B, and C. So I have just converting another example from start to delta. That is given. So what is the A value that I have just done? A value is P by Q, PQ by R plus Q plus P. Just putting those values. P into Q by R means 180, 150 by 60 and plus 180, 150, that is 780 ohm. So what is the value of B? That is given that B equal to PR by Q plus P plus R. So PR by Q, just multiplying PR by Q, that is 160 to 150 by 180 plus 60 plus 150, that is 260. So what is C? C is given as RQ by P plus R plus Q. So it is 180 into 60 by 150 plus 180 plus 60 equal to 312, and that is the equivalent of that particular star. That is the equivalent star of that, but that is we can convert a star connection to a delta 1. So we have to seen the three-phase balance supply and the power in a three-phase balance supply, and also the star and delta connection among the relationship between the voltage and the currents, and along with the conversion of star to delta and delta to star that we have already done. The delta to star conversion or star to delta conversion. Thank you.